The objective for this practical is to calculate and describe the following descriptive statistics: mean, variance, and standard deviation, and to understand the concept of correlation, and lastly to determine the relationship between the two variables. The material for this practical is leaf, ruler, weighing balance, and graph paper. The method for this practical is first take 10 leaves and then to measure and record their length and width, and then calculate the mean, variance, and standard deviation of the length and width of the 10 leaves, and then tabulate the data in the graph paper. Second, repeat for another 2 sets of leaves, so we will have 3 sets which give a total of 30 leaves from the same tree. Third, tabulate your result as a data matrix: mean, variance, and standard deviation for width and length for set 1, set 2, and the set 3. Fourth, use the data of all the 30 leaves to plot a graph of leaves length versus leaf width, and then state the relationship between length and width of the leaves if there is sort of relationship in it. So this is the result for the practical set 1, set 2, and set 3. There are 3 sets of data consisting of the length and the width of the 10 leaves each. Based on the data, the mean, variance, and standard deviation is calculated. The graph shows a linear trend between leaf length and leaf width. There is a positive relationship between leaf length and the leaf width. This indicates that an increase in leaf length is accompanied by an increase in leaf width. So this is a 4-step question. So question number 1 is discuss the differences of or similarity of the mean of length between different sets of leaf, and do the same with the mean of width. So based on the result obtained, the mean leaf length for the 3 sets shows some similarity and slightly differences. From this value, it can be observed that set 2 and set 3 have very similar mean leaf length, while set 1 has slightly smaller mean length. This indicates that the leaves in set 2 and set 3 are generally larger compared to those in set 1. However, the differences is not very large, suggesting that the leaves across all sets are relatively comparable in size. And for the leaf width, there's difference can be observed. The mean width increased gradually from set 1 to set 3. This shows that leaves in set 3 are generally wider, followed by set 2, while set 1 has narrowest leaves. Compared to leaf length, the variation in leaf width between the set is more noticeable. Overall, while the mean length are quite similar between sets 2 and set 3, the mean width shows clearer differences among the 3 sets. So question number 2 is what is meant by variance? The leaf have different measurement of width and length. What is the meaning of this statement? Discuss with respect to variance. What is meant by standard deviation? So, variance is a statistical measure that describes how far individual data values are spread out from the mean. A higher variance indicates that the measurements are more widely scattered, while a lower variance indicates that the measurements are closer to mean. The statement the leaves have different measure of width and length means that Not all leaves are identical in size. These differences is reflected by their variance value calculated for each set. Since none of the variants are zero, it shows that there is variation in both leaf length and width within each set. For example, some leaves are longer or wider than the average, while others are shorter or narrower. This natural variation is expected in biological samples such as leaf. Standard deviation is square root of variance and represents the average distance of each measurement from the mean. It is useful because it is expressed in the same unit as the original data. A larger standard deviation indicates greater variability in leaf size, where a smaller standard deviation indicates more uniform leaf measurements. In this experiment, the calculated standard deviation shows that there is moderate variation in leaf length and width across all sets. The third question is why it is necessary to have different sets of measurement for the measurement of leaf width and length. So it is necessary to have different sets of measurement to ensure that the data collected is reliable and representative. Using multiple sets allows comparison between groups and help identify patterns, similarities, or differences in leaf size. It also reduces the effect of random errors and natural variation, leading to more accurate and meaningful conclusions.
The objective for this practical is, firstly, to introduce the simple concept of quadrats, to enhance the power of observations, to record the differences in species distribution within the quadrats, to infer from natural observation the possible factors that affect distribution and abundance of organisms. The method that we use is one quadrat with size 5 meter times 5 meter and we put randomly on the ground. Next, we identify species within each quadrat and count the density using the formula as shown.
This is the result that shows a quadrat with divided 9 equal sections from section 1 into section 9. The percentage coverage of barnacles were observed and recorded. For section 2, it has the highest coverage of barnacles, which is 90%, and for section 9, it has the lowest coverage, which is 0%.
So we move to the posted questions. Firstly, define the term of quadrat in practice. So quadrat is a square-shaped tube in size 5 meter times 5 meter in a fixed area for ecological study. In practice, quadrat is used to estimate and record the distribution of organisms, population size, and species present in the habitat. Next, what are the basic requirements of all the quadrat technique? Firstly, the quadrat shape must be same of each sampling to get a consistent result and easy to compare. The second one is the quadrat must be placed randomly so that we can avoid the sampling bias and unfair data. So, what are the advantages and disadvantages of having a smaller and larger quadrats? For a larger quadrats, the advantages is more representative of habitat and we can observe more species. But the disadvantages is the time consuming is too long and hard to manage. But for the smaller quadrat, the advantages is the time taken is short and easier to handle. But the disadvantages is we can miss some of the species and not representative of all the habitat.
So, moving to the next question, which is issue concerns ecologists in conducting the sampling method. So, many challenges that ecologists need to face during sample in the large area. It's hard for ecologists to sample the entire area. So, by relying on the small plots, the whole habitat may be not represented. In addition, the limited ability to detect the organism. This is because some of the species can't be seen due to their dense vegetation, water depth, or their size is too small. So, this might be affect the population density in the area. So, what is the differences in the number of species in a quadrat? The number of species in a quadrat show the differences due to the environmental or abiotic factor. This is also known as microhabitat differences. Section 2 of the quadrat has the highest density of barnacles compared to other sections. This part of the quadrat exposed to the seawater. Barnacles live better on a moist surface. So barnacles depends on water to survive. Moist surface will represent barnacles from dying out at low tide. So they can keep their body hydrated to carry out respirations and feed efficiently. In addition, moisture helps barnacles to attach firmly and open their shells to filter food from seawater. So, this is why in section 9 and 8 there are less barnacles present in the quadrat.